Dear students, we are studying projectile motion, and in the previous lecture of projectile motion, we have studied a projectile motion which is an obliquely thrown object such that its initial velocity was u, the angle of projection was theta, and it was thrown freely in air under the action of gravity, and the acceleration due to gravity is equal to g, which is going to act in the vertically downward direction. So three things were known to me. First was the initial speed of projection u, the second thing was the angle of projection theta, and the acceleration due to gravity. By knowing this, we have determined or we have calculated several things, and the most important thing which we all have to remember in this projectile motion is that the velocity along the x-axis that remains constant u cos theta, it is not accelerated, whereas the part of the velocity or the component of velocity u sin theta, which is in the vertical direction, that is an accelerated motion. In this, what we have derived was the equation of trajectory of this projectile, the path which this projectile will follow, and we have derived this kind of equation that y is equal to, it is tan theta multiplied by x minus half g upon u squared cos squared theta multiplied by x squared. So this was my equation of trajectory. The path which this projectile will be following will always be obeying this particular equation, or it will always satisfy this particular equation for its x and y coordinates. We also have found how much would be the time taken by this projectile to reach till the maximum height. We have called it as time of ascent, and this time of ascent was proved to be equal to that of the time of descent, the time taken for this projectile to start from A and to reach till B, and to start from O to reach till A. Both these times they were equal, and that is equal to only u sin theta divided by g. The time of flight, the entire total time taken by the projectile, that was proved to be equal to, that t is equal to twice of this, that is 2u sin theta divided by g. This is also what we have done. Then, how much is the maximum vertical distance that the projectile would reach? We have derived an equation for this, which says that the maximum height the projectile would reach, that capital H, was found to be equal to u squared sin squared theta divided by 2g, and the maximum horizontal distance that the projectile would reach, this is called the range of projectile O to B, that was proved to be equal to, that range is equal to u squared into 2 sin theta cos theta upon g, which also can be equal to u squared into sine of 2 theta upon g. So all these things we have derived till now. This height h was also proved, this is also proved. Today we will be going for the different cases of range. When is this range of projectile going to be maximum? And while giving the examples of projectile, we have considered just an object thrown obliquely into air, and once you throw the object, later on the object is just allowed to fall freely under the gravity. So a stone or a ball which is thrown obliquely into air with initial velocity u making an angle equal to theta, it will always follow this kind of a motion, and that is called a projectile motion. The maximum distance that the object would cover on the ground, that is going to be the range. Now how are we going to have maximum range? If I want this range to be maximum, you can of course see that I must throw the object with larger initial velocity u, then the range would be greater. G is the value of acceleration due to gravity, and as that G is smaller, you can have greater range, but the value of acceleration due to gravity is not in our hands. You cannot change the value of acceleration due to gravity. The thing that I can do is that if I have got certain limit of throwing the ball, if I can throw the ball with certain maximum speed, which may be equal to, let us say, 50 meter per second, is the speed with which I can throw the ball, or if I can maybe say throw a ball to let us say 60 or 80 meters per second, that is the maximum speed with which I can throw the ball, and still I want to have the maximum distance covered, only thing that will be helping me is this value theta. The value of sine 2 theta is supposed to be maximum, so I would say that for maximum range you are supposed to have R is equal to R maximum, and that can only have value equal to u squared divided by G, but that is when you have sine of 2 theta value that is supposed to be equal to 1. Now I know that sine of 90 degree is equal to 1, or sine of pi by 2 radian is equal to 1. So sine theta is equal, sine of 2 theta is equal to 1 means 2 theta is equal to 90 degree, and therefore theta is equal to, it is 45 degree. Thus I can understand that if I throw the object with an angle equal to 45 degree, it will cover the maximum distance. The range of the projectile will be maximum when I throw it at 45 degree angle. So that is what I say, that for the maximum range you must have the object thrown at 45 degree angle. The angle of projection has to be equal to 45 degree, and only then the object will have maximum range. So whenever henceforth we have in problems that the object is thrown for maximum range, means theta is equal to 45 degree is to be taken into consideration. The second thing I understand, that I can have this theta, supposing if I am throwing this object initially with, let us say, 20 degree once and later on with 70 degree. The angles of projection, if they are complementary, that initially right now I have thrown this object at some particular let us say angle of projection called theta, and the range is equal to R is equal to u squared sine of 2 theta upon G. Now let me say that theta be replaced by the angle of projection 90 minus theta. So in that case, your new range of projectile, I would call it as R dash, that the new range of projectile will in this particular case become R dash is equal to u squared into 2 sine of 90 minus theta into cos of 90 minus theta entirely divided by G. But sine of 90 minus theta is equal to cos theta, and cos of 90 minus theta will be sine theta. So therefore R dash is equal to, it will be u squared into 2 cos theta sine theta upon G, which in fact is equal to same thing, u squared into sine of 2 theta upon G, which was equal to R itself, and therefore I find that R dash is equal to R for both the angles of projection theta and 90 minus theta. That is, if I throw a ball initially with 20 degree angle of projection and later on with 70 degree angle of projection, 90 minus 20, that's 70. In both cases, it will cover the same distance R, but the times and the you can say their trajectories, they would be different. So it will cover and reach the maximum same point when whatever your range was. So if you throw maybe a ball initially at 30 degree, later on at 60 degree, the range would be same. You throw once at 40 degree and then later on at 50 degree, the range would be same. So that is what we have studied here. Just now we have studied the relation of height, the maximum possible value of range, and we have also seen that the range is maximum for a 45 degree angle of projection, and the range of projectile is going to remain the same when the projectile is projected at the angles which are complementary to each other, theta and 90 minus theta. Now we will try to find what is the relation between the maximum height of projectile and the range of projectile, h and r. Finding relation between these two things, what I just do is I have named these equations, numbered them as something like equations 2 and 3. I will take ratio of equation 2 and 3. So if I do equation number 2 divided by equation number 3, that gives me here equation number 2 divided by equation number 3, that would give me that h divided by r is equal to, the value of h is u squared sine squared theta upon 2g, divided by r is the product with the reciprocal, that is equal to g divided by u squared into sine of 2 theta. Now here understand that this g will get cancelled, u squared will get cancelled, and therefore I get that this h divided by r is equal to, this is sine squared theta divided by 2 is still here, and sine 2 theta I would write it as 2 sine theta cos of theta. So this one term of sine theta will get cancelled. This is only equal to like sine theta upon cos theta will give me tan theta. 2 into 2 is 4. So I get h upon r is equal to, it is 1 by 4 tan of theta. And therefore I will find that this h is equal to r by 4 times of tan theta. So this is the relation between h and r. The height of projectile, that it can reach vertically maximum height, and the range, they are always related to each other with this particular thing. Also just now we have spoken that the range would have maximum value. This r will be equal to r max, and that r max is only equal to u squared upon g. But I can also find that this value of r max is there for theta is equal to 45 degree. So if you have for theta is equal to 45 degree, that the angle of projection is 45 degree, that r is replaced by r max, I can say, and therefore this equation of mine can now become that therefore h is equal to, it is r by 4, instead of that I would write it as r max divided by 4 into tan 45 is 1, and therefore you find that r maximum is equal to, it is 4 times the height. So this happens to be a very important relationship. Whenever a projectile is thrown for the maximum range, if the problem says that the projectile is thrown for the maximum range and the maximum range is equal to 100 meter, it is but obvious that if the range is 100, the height has to be equal to 100 divided by 4, that is equal to 25. The maximum vertical distance that it would reach is equal to 25. If the maximum range is 80 meter, that h value is supposed to be equal to 80 divided by 4, that will give you 20. If you say that the projectile is thrown for the range of let me say 1 kilometer entirely, for maximum range is equal to 1 kilometer, that is 1000. So the maximum height it is supposed to reach is 1000 divided by 4, that's equal to 250 meter. That is what is the conclusion from this particular equation. Hereafter we are also going to try and have a relation which is not most of the times needed in our normal SSC, HSC syllabus, but it is required for solving some tricky examples in JEE NEET kind of things, and that is the relation between x, y, theta and r. So that is what we would be going for the next. Well, so most of the times in projectile motion, whenever we talk about a projectile motion, we say that the initial speed u, theta, g, they are known to us, and we can find several things. Now I go for what is the relation between x, theta, y, that is x, y, theta, and the range of the projectile. So even if your initial speed of projection is not given to you, but if the angle of projection is given to you, or even let us say that is given to you, and even the range of projectile is given to you, at certain value of x, you can find what is the value of y coordinate in that case. Let us say I take into consideration this equation number 1 and I try to simplify that as y is equal to, we already have y is equal to, it is x tan theta minus half g upon u squared cos squared theta into x squared. Out of these two terms, let me take x tan theta common. So I take, it is tan theta into x is common, and inside the bracket we will be left with 1 left from here, minus all this term is going to be there, minus half g upon, it is u squared cos squared theta. One term of x also has been taken out of this, and one more tan theta I have taken out, but there was no term of tan theta here. So I must keep this tan theta term in the denominator. So it's going to be tan theta over here. That is what it will give. Now I'll just simplify my term of tan theta here, and I get that therefore y is equal to, it is x into bracket tan of theta is going to be here. Inside the bracket 1 minus g by 2 into x upon u squared cos squared theta, and here instead of tan theta I would write it as sin theta upon cos theta will go upstairs. One term of cos theta I find gets cancelled. This g I would further write it in the denominator, and it gives me y is equal to x tan of theta inside the bracket 1 minus, it is x divided by u squared multiplied by 2 sin theta cos theta, means this is sin of 2 theta, and all this is divided by g. So mathematically I have written everything correct. And there I find this entire term u squared sin of 2 theta upon g actually is the range of projectile, and therefore I get y is equal to x into tan of theta inside the bracket 1 minus x upon r. So that's probably some equation number 4 for me, I would call it as. How is this equation going to help me? That supposing if it is told that a projectile was thrown initially, let me say at 60 degree, and it is going to cover the range of 80 meter. So if I have, so if at all you have theta is equal to 60 degree and the range of projectile is going to be equal to, let us say, 80 meter. So thrown at 60 degree, it will reach up to 80 meter here, and I want to find At x is equal to 20, what is the value of y? So at x is equal to 20 meter, y is equal to how much? Now this will help me. Otherwise, to find the relation between x and y, I usually need this value of u. Here that is not required. Let us see. So I would have here that y is therefore equal to, if I just start simplifying this, it is x tan theta, that is 20 into tan of 60 is root 3, inside the bracket 1 minus x, that is 20, divided by r is equal to 80. So this gives me 1 by 4. 1 minus 1 by 4 is going to be equal to 3 by 4. So it is 20 root 3 multiplied by 3 by 4. This is 4 5s are 5 3s are 15 root 3. So many meter I would find. So when the projectile was thrown like this, and if it was having the x coordinate equal to 20, the y coordinate at that instant would be equal to, let us say, 15 root 3. What if this x was exactly in the middle, x value 40 as the x value 40 as well, I will have to put here 40. So it will be 40 root 3 into bracket 1 minus 40 by 80 is half. So 1 minus half is half. So 40 root 3 into half will give me 20 root 3. So when you have x is equal to 40 here in this case, for x is equal to 40 meter, you will find by solving that y is equal to 20 root 3. Now whether this is correct, that also can be checked by using the earlier equations which we have found for the relations between x and y, where we have said that h is equal to 1 by 4 times of tan of theta. So that also would give me this particular relation to be correct. So that's what we wanted to go for, and in the projectile we have almost covered everything in the part of theory of projectile motion. In the next video we will be speaking and solving some more problems regarding projectile motion. Thank you.